So in last video, as a part of divide and conquer technique, we covered very clearly about what is mean by quicksort, how we can able to work with the quicksort. I explained very clearly. I mean merge sort, I explained very clearly. So in today's session, we are going to talk about quicksort. In today's session, we are going to see how this quicksort is going to work. So it is also a beautiful sorting technique which is available, but the technique followed by quicksort is nothing but here they are going to use one special element called pivot element. They are going to use one special element called pivot element. Based on that element only, all the things are going to be happen. Sir, how it is going to work? I will demonstrate with one example. We will see how it is going to work. Let us see. I'm going to take some elements. Okay, like let us consider some elements I'm going to take in the form of like this. So 6 is nothing but the first element. Next and after that 4 is another elements. So another element. 5 is nothing but another element. Next 1 is the next element. 8 is the next element. We are taking 2 as the next element. So 9 as the next element. 7 as the next element. So 10 as the next element. 3 as the next element. What we are going to do is, here we are going to select one special element from this list. Okay, we are going to select one special element from this list. What is that special element? Sir, do you know that element is called as, that element is called as pivot element? Okay, here we are going to select one special element. What is the name of that element? I am telling pivot element. We are going to select one specialized element called pivot element. It can be any element in the list. Some people may select the first element as a pivot element. Some people may select the last element as a pivot element. Some people are going to select the middle element as a pivot element. Like it can be any element. It can be any element from the list. So consider in this example, I am going to select the first element as a pivot element. Sir, what is our target here is, whatever elements are there lesser than these pivot elements, we have to bring towards left side. Sir, is 4 is lesser than pivot element? Yes. Is 5 is lesser than pivot element? Yes. Is 1 is lesser than pivot element? Yes. Sir, is 8 is lesser than pivot element? No, 8 will come to the next side. 2 is the pivot element, less than pivot element? Yes. 9, it is greater. 7, it is greater. 10, it is greater. 3, it is lesser. So now pivot element will come into the middle. And you can see the less than elements from, the less than values of this pivot element is moved to the left side of the list. Okay, you can see 4, 5, 1, 2, 3, all these elements are lesser than pivot. And you can see in the right side, we have the elements which are greater than 5. So which are those elements? 8, 9, 7, 10. Like this we have. This is nothing but how you can able to represent list. This is the first pass. Now this process we are going to repeat recursively. Okay, this process we are going to do recursively. Sir, how it is going to work with recursion? Very simple. This element, this list will become another sublist. This one will become another sublist. Here take the pivot element as a 4. Then is 5 is less than 4? No. So move to the right side. Is 1 is greater than 4? No. So move to the left side. Is 1 is less than pivot element? Yes. Is 3 is less than pivot element? Yes. Now your 4 is already in the list. Like this, we have to repeatedly do for left subarray and right subarray. Finally, what will happen? The elements will be sorted in ascending order. This is nothing but the technique followed by pivot quick sort. In the quick sort, the main variable here we are using is nothing but pivot. Based on pivot only, we are going to perform this sorting operation. I think you people understood what is the agenda of this particular one. So any
Yes,
doubts in this? Is the concept is clear? Please confirm everyone.
Yeah, sir.
Yes, sir.
Right. So we will implement this particular algorithm and let us check how it is going to work. So I'm taking a Python program. So what I'm going to do in this Python program is I will create one quicksort algorithm. I'm going to create one quicksort algorithm. Let us take the list of elements are something like 3. So 4 or 3, 5. So 4, 2, okay, 1 and then 6. Like this I'm taking. Now, before performing quicksort, what are the elements? After performing quicksort, what are the elements? For the quicksort, the input what I am giving here is nothing but I will give the list and I will pass the minimum index, which is nothing but 0. Then the highest index, that is maximum index, which is nothing but length of the list minus 1. So now this 0 is nothing but a starting index within the list and length of the L. How many elements are there? 6 elements. 6 minus 1 means 5. 5 is nothing but the ending index value. Like these two indexes we are providing. With the help of this, what we are going to do, we will implement a recursive call and let us check how that recursive call is going to work. Sir, here I am going to define quicksort algorithm. I am going to define quicksort algorithm. So which is going to take, already we have taken the method name as a quicksort. It is going to take a list and low value it is going to take high value, something like low pointer and high pointer. Suppose if your high pointer is less than or equal to low pointer, there ends the task. Since it is a recursive calls, we are going to return empty. So immediately the control is going to be transferred when if the value of high is less than low. So when this situation will come, if all the sorting is completed, so at last this one will come. So next we have to pick up a pivot element. Based on this only we have to do the operation, right? So pivot element I am considering from the list always the first element. Sir, you can take so last element also, no problem. Okay, pivot element I am selecting A of low. Then I am going to give the start index is equal to, so A of the start index is equal to, I will take the value of low, and end index is equal to, I am taking the value of high, because we are going to change the value of low and high to retain the original positions. I am taking start is equal to low and end is equal to high. I will write a loop. What is that loop is, until your low value is less than high, until your low value is less than high. So what we are going to do, we have to do the comparison process. So I am taking while L of low, while L of low is less than or equal to pivot element or not, we are checking. At the same time, is your low value is less than high also, we are checking. If this condition is satisfied, your low value we are incrementing by 1 unit. Your low value you are incrementing by 1 unit. Sir, otherwise what will happen? So greater elements we have to find out. So L of high value I am taking. Is it greater than pivot element or not, we are checking. And your low value is less than or equal to high value or not, we are checking. If it is satisfied, so your high value is there, right? That high value minus 1 I am taking. This is nothing but the thing what happens. Sir, let us check what will happen in this by taking one simple example. Consider the list what I have here is, so consider I am taking 5, okay, something like 3, okay, and then 7, okay, and then 8, and then 2, and then 4, like this I am taking. So this is 0th location, this is a first location, this is second location, third location, fourth location, fifth location. So we are taking pivot element as a of low. That means this element will become pivot element. Then your start value is 0, your low value is also 0. Your high value is 5. Your end value is also 5. Keep it in mind. Is low value is less than high? Yes, right. Then A of low. What is a A of low? That is 5. Is it less than or equal to pivot element? Yes. And low value is less than high value. Then low will become low plus 1. Now your low value will become what? 1. Now we are checking 1. So A of low. What is a A of low? The element is 3. Is it less than or equal to pivot element? Yes. And low value is less than high, right? Then low is equal to low plus 1. That means now your low is pointing to 2. So what is the meaning? The element 3 is less than 5. That is the meaning. Now see what will happen. When L is equal to 2, we are checking L of low. The element is 7. Is it less than or equal to pivot element? No, right? Then it will come out. We are checking the last element. So A of 5, what is the last element? 4. So is it greater than pivot element? What is a pivot element? 5. Is the condition is satisfied? No. It will come out from this. Now again we have to check one more condition. What is that condition? Is your low value is less than high or not? We are checking. Yes, right. Then we are going to swap L of low, L of high, okay, with L of low is equal to again L of low with L of high. So just I am performing swapping operation. So which two elements will be swapped? You can see. What is the high value here? 5. So A of 5 and then A of low, A of 2. These two are going to be swapped. Here 4 will come, here 7 will come. Now observe carefully. Again low value is less than high. 5 is less than 5. Sorry, 2 is less than 5. Condition satisfied. Again this process is going to be repeated. A of low. What is a A of low? Low value is 2. A of 2 is nothing but 4. Is it less than or equal to pivot element? Yes. Your low will become low plus 1, 3. Okay. Task is completed. Then again L of 3 I am taking. What is a L of 3? 8. So is it less than or equal to 5? Condition is not satisfied. Then what we are doing? We are checking in the right side. So L of high value is 5. So the element which is available at 5th location is 7. Is it greater than pivot element? Yes, condition satisfied. Is low value is less than or equal to high? Yes. Then high is equal to high minus 1. Your high value will become 4. So again, we are going to repeat this loop. L of high value is reduced, right, to 2. Is 2 is greater than 5. Condition not satisfied. So first loop also failed, second loop also failed. Now we are checking, is low value is less than high. Is low value is less than high? Yes. Then change the positions. So in low pointer we have 8, in high pointer we have 2. These two we are going to interchange. Now low value is 3. Is it less than high? Yes. Try to take A of low. A of 3 is nothing but what? 2. Is it less than or equal to 5? Yes. Then low is equal to low plus 1. Then is A of low. What is a A of low? 4th location, 8. Is it less than or equal to 5? Condition not satisfied. Is high value. What is a high value? High value is 4. So is that 4 is greater than 5? Yes, condition satisfied. Is your low value is less than or equal to high? Yes. Then high is equal to high minus 1. Your high value will become 3. Okay. Then again L of high. L of 3 is nothing but what? 2. Is it greater than 5? Condition not satisfied. It will come out from this. Is low value is less than high value? No, right? Then it won't perform swapping. Now if you see very clearly, the elements which are lesser than pivot element are arranged in the left part, and the elements which are greater than pivot elements are arranged in this. But we have to bring this pivot element to here, right? For that we are going to write one condition where out of this loop. What is that loop? Is so L of your high value is there, right? L of high value is there, right? That I am going to swap with L of your start value is equal to L of your start value. Okay, is swapped with L of your high value. So tell me what is the position of high? 3, right? In third location, which element is there? 2. So that 2 will come to the beginning and 5 will go to the here. Now what is the updated list that you are going to get? So 2, 3, 4, 2, 3, 4, 5 and then 8, 7. You can see this is the pivot element. The elements which are less than pivot are available here. The elements greater than pivot are available here. Now you have to take this as a sublist, this as a sublist. Again we have to solve. So how I am going to call those functions? Very simple. Again we have to call the same quicksort function. I am calling quicksort function. Okay, so by passing that list as it is, I will pass the starting index value. Starting index value. What will be the ending index value? Sir, is it the value of I minus 1 or not? Yes. Now again I will call the same quicksort function. So by passing that list, and what about next value? Your high plus 1, your high plus 1 to end value we have to take. That is something like merge sort. We divided into two parts. This is the scenario how this particular loop is going to work. I think you people got very clear clarity about this. So can you please confirm everyone is the concept behind this? Is it clear for you people, guys?
Yes, sir.
Right. But we will check really whether it is going to work or not, because we need to cross check, right? So now I am taking Java C test.java to compile the program. Sorry, it is not Java program, right? It is a
It's a
Python
Python.
program. Yeah. So I'm taking py space test.py. So you can see before sorting, the elements present in the list is nothing but 3, 5, 4, 2, 1, 6. After sorting, the list contains 1, 2, 3, 4, 5, 6. This is nothing but how you can able to implement which one? Quicksort algorithm. Can you please confirm? Do you have any doubts up to this? Is the concept is clear for everyone?
Yes, sir. Clear.
Right. So this is nothing but a quicksort algorithm what we have. So it is a part of divide and conquer technique only. It is a part of divide and conquer. With this, all the sorting techniques we completed. All the sorting technique we completed. Okay. So even the strength is very less. I am going to close today's session. So tomorrow we are going to start which one? Sorting algorithms completed, divide and conquer completed. Tomorrow we will start a searching algorithms, sir. What are the different types of searching algorithms are there? Tomorrow we will start. Maybe
Sure.
up to Monday or Tuesday I'm going to cover searching. Then we will go with these beautiful concepts. Okay.
Sure.
Okay,
Right.
sir. Okay. Thank you, sir.
Thank you.
Right, sir. Thank you. We will see you tomorrow.